Okay, lecture 2 for our statistics class. We're going to talk about qualitative versus quantitative data. Okay, do you remember yesterday? Well, I say yesterday, but I meant lecture 1. We said there's 2 types of data. Okay, we said there's categorical and numerical. I'm going to just replace those words just to make them sound a little bit more fancy. Instead of categorical data, let's call it qualitative. Why? Because categorical data is things like hair color. What else? Type of car. Things like that. Things that fit into categories. Okay? Well, those are qualities also, aren't they? Like if you have black hair, then that's a certain quality that your hair has, the quality of being black. Okay? Or it could be blonde or anything else. Okay? It's a category that's based upon a quality. So statisticians will usually use the word qualitative instead of categorical. And what do numbers do? Numbers represent quantities. So instead of calling it numerical data, we're now going to start calling it quantitative data. Okay? And we didn't say this yesterday. This is new. Quantitative data can be found in 2 different kinds. There's discrete quantitative data, and there's continuous quantitative data. Discrete quantitative data means that there's only certain values that can be taken on. Okay? For instance, let's say you were going to go around the building I'm in to every classroom and count how many people are in the classroom. Okay? There's only certain numbers that you're going to find. There's infinitely many possibilities, but what I'm saying is this. You're not going to find 11 and a half people in one room, because there can't be any halves. It would have to be whole numbers, right? If there's more than 12 people, then the next possibility jumps all the way to 13. It skips over 12.2 and 12.7 and all of that stuff. Okay? That's discrete. Continuous quantitative data is quantitative data where the possible numbers, not just the numbers that you actually end up with, but the possibilities, could flow like a number line continuously. You see, in fact, I'm glad I said number line. That's a good example. You see, discrete data is where it's like separate points on a number line. Okay? And continuous data is where it's a range of numbers, maybe like a certain interval. Okay? I'm going to give you some examples right now to make sense of this. It's a pretty short topic today, okay? It's just learning these 3 categorizations, okay? Is data qualitative or quantitative? And if it's quantitative, is it discrete or continuous? So you always have 3 types of data. There's qualitative, there is discrete quantitative, and there's continuous quantitative. Okay, so let's do some examples. Okay. You time how long the phone calls are that you make in 1 week. Okay? Let's write that down. The length in time of the phone calls you make in a week. Now, for the sake of argument, we are going to say that you have an infinitely accurate stopwatch, okay, that could measure time down to the exact instant. Most stopwatches only go to like 100th of a second or something like that, but let's pretend you have a perfect stopwatch. Okay, so the first part of this is very easy, I hope, to determine if that's qualitative or quantitative data. So you would write down the times, okay, let's say in minutes. So in fact, let me change that. It says in time. Let me actually say here in minutes. Okay, so you would get numbers like maybe this, maybe 12.7 minutes, maybe 5.43 minutes, maybe 28.1 minutes, maybe a quick call that's 0.752 minutes. Okay, let's just say you've made those 4 phone calls. Now, first part's easy. Is it qualitative or quantitative? Well, look, they're numbers, right? That's almost always going to be quantitative. I mean, I suppose you could have numbers be qualitative only if you forced that to happen. Like you could say you're going to record people's hair colors, but then instead of actually writing down the color, you could assign a number to each color. If someone has black hair, you write a 1. If they have brown hair, you write a 2, and things like that. Then you'll be writing down numbers, but the numbers would be representing categories. So even though they're numbers, they would still be qualitative in that sense. Okay, but 99% of the time, if they're numbers, they are quantitative. But to be sure, here's what you ask yourself. Are you measuring a category or a quantity? Okay, so we are measuring the number of minutes of the phone calls. That's a quantity. So that's quantitative data. Okay, I think that's pretty easy. Now, the next part, which you sometimes have to think about is it discrete or continuous? Okay, so the key is that I said, let's pretend you have a perfect stopwatch. Okay, so under that assumption, then this would be continuous quantitative data. Okay, if you did not make that assumption that I said, that you have a perfect stopwatch, if you had a stopwatch that only went to 100ths of a second, then that technically would be then discrete, because once you went longer than a certain 100th of a second, the only next choice is to jump all the way to the next 100th. Okay, but that's not the situation I described. I described a perfect stopwatch where it could give you any number of decimal places. Okay, so that would be continuous quantitative data. Okay, here's another example. You go to the supermarket, You'll see this in the book if you read in the book. This is example 1.7. You go to the supermarket and purchase 3 cans of soup, a 19-ounce can of tomato bisque, a 14.1-ounce can of lentils, and a 19-ounce can of Italian wedding soup. So I guess that's not, the second one I guess wasn't a can of lentils, it's a can of lentil soup. I should have been more careful there. Okay. You also bought 2 packages of nuts. It's a package of walnuts and a package of peanuts. And you bought 4 different kinds of vegetables: broccoli, cauliflower, spinach, and carrots. And you bought 2 desserts, 16-ounce package of pistachio ice cream. I don't know why anybody would buy pistachio ice cream. And 32 ounces of chocolate chip cookies. Okay, that's a lot of information. Let me write it down. Okay, so let's put here, this is your grocery list. Okay, and there was soup. And okay, so there was tomato bisque. And that was 19 ounces. There was lentil soup. And that one is 14.1 ounces. And Italian wedding soup. And that one is how big? 19 ounces. Okay, then you also bought nuts. Okay, there's peanuts. And walnuts. Okay, 1 package of each. We aren't given any size of that package, so I won't make up anything. I'll just leave it like it's given to us in the book. Okay, and then vegetables. All right, we got some broccoli and cauliflower. I happen to really like both of those. Most people don't. As long as they're not overcooked. I hate it when they're overcooked. Spinach. I don't like spinach unless it's raw. If you ask me, if you cook spinach for 1/10 of a second, it's already overcooked. And carrots. Not a big fan of carrots. All right, and then dessert. When I was a kid, I used to gag if I had to eat cooked carrots. That's how much I hated cooked carrots. Okay, so we want some pistachio ice cream. And that is 16 ounces. And chocolate chip cookies. How big is that package? 32 ounces. Okay, that's our shopping list. So here's the question I want to explore with you. It's not just one single question. The question is, let's look at that list and let's find examples that you could pull off of that list of quantitative discrete data, qualitative data, and quantitative continuous data. Okay, there's lots of examples of different kinds of data here, so let's do that. Okay, so let's do quantitative first. So in other words, remember, did I say quantitative? I'm sorry, I meant to say let's do qualitative first. So remember, qualitative just means categorical. So what kinds of categories do you see there? I see different levels of categories. Like, for instance, you could say, what are the main categories on my shopping list? I see soup, nuts, vegetables, and dessert. So that right there is one type of qualitative data from your shopping list. Okay? Would be, what are the different aisles that you have to go down? Let's just pretend there's a soup aisle and a nut aisle and things like that. Okay, and the data points would be exactly what I highlighted. There would be 4 data points in that data set. And the 4 data points would be soup, nuts, vegetables, broccoli. Okay? What other possible sets of qualitative data do you see? Here's one. You could say, what kind of soup am I going to buy? And I see 3 data points in that set. Tomato bisque, lentil, and Italian wedding. Okay, what kind of soup am I going to buy? You see, those are categories. Now you could say, what are the sizes of the soup cans I'm going to buy? Let's see if I can get a different color here. What are the sizes of the soup cans? So that would be, sorry, I don't mean to be taking up your time. I'm having some trouble with the colors of the pens. So that would be these. Is that quantitative or qualitative? Those are numbers, so measuring quantities. So they're quantitative. Are they discrete or continuous? So again, this, you have to, don't be too quick to answer discrete or continuous. You have to actually think about it a little bit. That would be continuous. Now, I know this, you might say, no, it's discrete. It's either like 19 or 14.1, nothing in between. When we say continuous or discrete quantitative data, we're not asking, were the numbers that you obtained continuous or discrete? We're saying, were the possibilities of what a number could be continuous or discrete? So it just so happens that these cans of soup were made in certain sizes. But the point is this, they could have been made any size at all. You see what I'm saying? Instead of 14.1 ounces, it might have been 13.987635 ounces. You see what I'm saying? It could have been any size. It just so happened to be 14.1, but it could have been anything. So the purple ones, that is a set of continuous quantitative data. Okay? Now, what else can we see? Well, the same idea in other places, right? Like you could say, you could do a survey of what kind of nuts am I going to buy? And in that case, that's qualitative data. And there's 2 data points, and the points are peanuts and walnuts, right? Here, broccoli, cauliflower, spinach, carrots. That's qualitative data where the question is, what kind of vegetables am I going to buy? Same thing for desserts. And similar to the sizes of the soup cans, we have the sizes, or let's say the weights of the packages of the desserts, right? This is quantitative. And again, it's continuous because they could have been anything. I know they just so happened to come out at 16 and 32, but they could have been any size. I did not find any discrete quantitative data. Can you think about, is there any discrete quantitative data in this list? We can find some. How about this? What if I asked the question, how many items am I going to buy? Oh, that's on the list, isn't it? What's the answer? The answer is 11. I'm going to buy 11 items. That's quantitative because it's counting the number of items. And it is discrete because it can only be whole numbers. I can't buy a fraction of an item, right? So the number of items I'm going to buy, that would be discrete quantitative data. And for this particular list, I would get one data point, which is the number 11. Okay, does that make sense? I hope it does. And if it doesn't, if you need to see the same thing, typed up neatly, you can look on page 10 in the book, but they didn't make a nice, colorful list like I did, so I like mine better, but you can see it on page 10 if you want. Okay, now we're going to do one more example, and then that's going to be all for today. And this is on page, where are we here? This is on page 11 of the book here. It says, it's a pie chart, okay, and it says, a statistics professor collects information about the classification of her students as freshmen, sophomores, juniors, and seniors. The data she collects are summarized in this pie chart. What type of data does the graph show? Okay, let me do this for you here. Let me draw a nice pie chart. Okay, and here's what we have here. Let's do blue. Okay, and that represents the number of freshmen. Okay, and then the next smaller group is green. Let me do those in a different direction so it stands out more. Okay, and green represents the sophomores. Okay, let's use red next. This will be the juniors. And I need one more color. We can still use black. And that'll be the seniors. Okay, so that's the pie chart that we get. The question was, what type of data does this graph show? So our choices are qualitative, quantitative discrete, and quantitative continuous. Okay, so what do you think? Think about that for a minute. And I could see different answers with, that you can make a good argument for the answer. I believe that there is one correct answer to this particular question. But I could totally see that you could make an argument for other answers and be pretty close. I don't think you would quite hit the mark, but you'd be pretty close. Okay, do you have your answer? So I would say that this is qualitative data because it's only showing categories. Now, you might say this is what I was talking about, that you might make an argument for quantitative, because you might say, yeah, but it shows us the size of the categories. That's true. It does show the relative size, but there's nothing in the chart that actually says what the sizes are. I mean, I could tell that there appears to be a lot more freshmen than anything else. And you know, and the second biggest group is the sophomores, and then the juniors, and then the seniors. Okay, but the graph doesn't explicitly show me any quantities. So the way the graph is written right now, it is showing qualitative data. It is showing categorical data. It's got 4 categories. Okay? Now, if we were given more information, like if there were percentages marked, then we would also have some quantitative data. Okay, it's possible. This is not what the case was, but it may have been the case that, you know, they might have said something like that 70% of the class is freshmen, and maybe 18% is sophomores. I'm just eyeballing this. And maybe 10%, well, let's say maybe 9% here is juniors, and 3% is seniors. If we had been given that information as well, then we would also have some quantitative data. Would it be continuous or discrete? That would be continuous. Just because I happen to write down whole numbers there, but that doesn't mean that it's discrete, because I could have written down 70.345, right? I just didn't happen to. But the percentages could have been any number continuously between 0 and 100, right? So the percentages are continuous qualitative data. Now, if they also told us that there's 50 students total, then we would have some discrete quantitative data, which is the numbers of students. We would say there's 35 freshmen, 9 sophomores. Oh, I guess it kind of falls apart here, doesn't it? I would come out with 4.5 juniors. We better change these numbers. Let's make that an 8%, and the seniors a 4%. So then we'd have 35 freshmen, 9 sophomores, 4 juniors, and 2 seniors. So the way I have it written there, I see some qualitative data, which is the 4 categories: freshman, sophomore, junior, or senior. I see some continuous quantitative data, which is the percentages. And it's not written down, but we said that if we knew the total number of students, then we would also have some discrete quantitative data, which is the number of each student in each category. Okay? I'm dancing around one issue a little bit, and I'm going to mention it just in case you're thinking of it, and that is, I said that the percentage is continuous quantitative data because I said they don't have to be whole numbers or anything like that. It could have been anything, right? But then as soon as I wrote down the 50, that kind of changed that a little, didn't I? If there's 50 students, then there could no longer be, for instance, 70.1% freshmen. So as soon as I added that 50, then I guess technically the percentages now become discrete. But when I had said that originally, the 50 students had not been added yet. so there's no telling how many students there would be. There could be 1 million students in this class for all I know. Okay, I think we don't need to worry about those little points, okay? Because I'm just trying to get you the idea right now of the 3 different kinds of data, and let's not split hairs about things like that, okay? If you're trying to decide between is quantitative data continuous or discrete, and if you're going back and forth and splitting hairs, then honestly I would say you're trying to put too much thought into it. It shouldn't be something that requires that much thought, okay? Don't overthink it is a very useful phrase that I would say there, okay? If you have questions about it, if it's confusing for you, just log on to the Zoom discussions and I'll help you through it, okay? All right, I will talk to you guys later.